All right. So let's just look at, I want to look at the third one real quick. Number 3 that's on here. So we have tangent of theta times cosine of theta plus the cotangent of theta times 1 minus sine theta equals cosine squared theta. All right, so if we want to verify this identity, which side do you think we should work with, the left or the right? The left. Remember, again, we want to try to work with the more complicated side and make it look like the less complicated side. Simplify the more complicated side. So, we look at the left-hand side. Oops, it's cotangent theta. What do you think we should do first? Or what's an idea of something to try first?
Change. I was about to say change the 1 minus sine theta to cosine theta.
That won't work. Yeah, that's a common thought, though, that people want to try to do. Remember that one of the identities we do have is 1 minus sine squared theta equals cosine squared theta, right? That's just a rearrangement of the sine squared equals cosine squared equals 1. Okay? But we do not have this one. This one doesn't work. Okay. See, I think what we'll do first here is distribute, maybe. Yeah. So we would have. I'll distribute this one first through the first one. So we would have tangent of theta, cosine of theta, plus tangent of theta, cotangent of theta. But I still have this 1 minus sine theta hanging out here. We just distributed it first through the first one. Okay, I think you could absolutely do the FOIL if you wanted to. I think I would simplify inside first just to help us out. Yeah. Oh.
So I was going to say, would the inside simplify to sine theta plus 1?
Yeah, I agree. So remember, one of the things that we can do is let's change things around with some other identities we have. Well, how can we rewrite tangent? Sine over cosine. And what's the relationship between tangent and cotangent? They're reciprocals of each other, right? Yep. So in the first term, we would get the cosines go away, and in the second term, we just get a 1, don't we? Okay.
So you want to multiply tangent with the sine?
Say it again.
Because it's outside the parentheses, so I thought like you would multiply tangent both times cosine and 1 minus sine.
So I don't want to distribute it over both of them because there's not a plus sign.
Oh,
Here.
okay.
Okay, so I just have 3 different factors, so I just need to multiply 2 of the factors together. Okay. All right, so now what can we do here in this next step? Let's FOIL it, right? So I get sine of theta and minus sine squared theta, and then plus 1, and then minus sine theta. Anything good happen there? Good. The 2 sine thetas cancel out with each other. And if I rearrange it, I can write it as 1 minus sine squared theta. And that's our identity of the 1 minus sine squared theta is cosine squared theta. Yeah. So we got to the last step that we needed. So this one again illustrates a couple of things we talked about last time. We talked about replacing tangent with sine over cosine. Here's another one of the reciprocal identities, right? We've got this idea of simplifying the more complicated side. And then here again, I meant, like we mentioned last time, make sure you're paying attention to those Pythagorean identities. But it also illustrates the be careful ideas, right? This is very tempting to try to do. You see 1 minus sine squared or 1 minus cosine squared so many times to replace it with the other, you forget that you can't do it if it's not squared. That's okay? All right, I want to do one more, and then I'll get you started on the quiz. Let's look at number 7. Illustrates another, well, actually it illustrates 2 points that I want to illustrate. All right, so number 7 has 1 minus sine to the 4th x over cosine squared x equals 1 plus sine squared x. Which side do you want to work with, do you think? I probably want to work with the left as well. Good. All right. Now, much like in the previous problem, where this was tempting, this one we've got this. What's tempting? Yeah, it's tempting to do that, right? Guess what? Nope, that doesn't work either. Okay? You gotta be very, very careful, right? Again, like I said, you see 1 minus sine squared, 1 minus cosine squared so many times, you're just kind of trained to flip it out. It's an important property to remember that it's just the squares, okay? Now, there is another trick that we can do with this to help us out. I can think of the sine to the 4th as a sine squared squared. That's certainly true, right? A 4th power is just a square that's been squared again, correct? So this requires us to remember a little bit of algebra. If you've got a squared minus b squared, how can I rewrite that? Yeah, good. That's a difference of 2 squares, correct? Okay. Right? So, yeah.
Would you be able to change the cosine square at the bottom to 1 minus sine squared?
You absolutely can. Yep, you absolutely can. Yep. That's perfectly allowed. If you wanted to replace the cosine squared with 1 minus sine squared, you can absolutely do that. Yep. All right. So how does this help me, this factoring idea? Yeah. Good. Is they do what she just said, one way or the other. Good. So if I think of this as 1 squared, right? Because 1 is the same thing as 1 squared, isn't it? Then this is my A, and this is my B for the A squared minus B squared. We just factored it. This happens quite a bit, by the way, in identity type of problems, where you need to look for factoring, and in particular, factoring a difference of squares. And this popped up quite a bit. So we can factor it, and then like Taylor said, we can replace the cosine squared x with what? 1 minus sine squared, or replace the 1 minus sine squared with cosine squared, either one. Yeah.
Did you square the 1? Is that a square?
This one, I just said you can think of 1 as 1 squared, so you could see the difference of squares.
Okay.
I just wrote it that way so you could see the difference of squares. It doesn't have to be there. Yeah. Okay. So if I leave the top the same, like Taylor said, we could replace the cosine squared x with 1 minus sine squared x. And then what can we do? Cancel. And we're left with exactly what we're trying to get to. Right? That's okay? I do want to mention a couple of other identities that pop up in the Hawks homework. So just to write it down. We've talked about them before, but just to write them down. We had those cofunction identities. Remember, these just say that the reason why they're called cofunction identities is the idea for complement. Sine of an angle is cosine of its complement. Cosine of an angle is the sine of the complement. And you got the other ones with the tangent and cotangent. These just come right out of the right triangle relationships. Because if you think about the right triangle, if you look at the complementary angle, the opposite side becomes the adjacent side and vice versa. That's where these come from. Again, the reason why I'm writing these down is that you'll see them in some of the Hawks homework and stuff. They have a couple of other ones that pop up with adding in pi, for example. Oops. If you add a pi inside of sine or cosine, it negates the sine or cosine. There's similar ones for secant and cosecant. If you add a 2 pi, well, that's just the period, so it doesn't change it at all. So if you had a sine of theta plus 2 pi, it would just be sine of theta. Again, the only reason why I'm mentioning some of these is because they pop up in the Hawks homework. So just
What are those ones called? Those bottom ones?
these, they don't really have a name. If they do, I don't know what it is. What's that? When's the Hawk homework due? On this section, I think it's due on Tuesday, maybe Thursday, 25th. So Tuesday. All right, we're ready for a quiz?
Okay.
No? No. Too bad, we're ready for quiz. All right. Again, when you're done with your quiz, you can go. We'll practice some more identities on Monday as well. There's only one more section that we're going to do before the next test, by the way. So we're going to spend a good amount of time on identities.
Got a little time.